This Fleet Equipment Unscripted interview is presented by Hendrickson, a leading manufacturer of heavy-duty suspension systems and components to the global commercial transportation industry. Visit hendrickson-intl.com to learn more.
Hey everyone, Jason Morgan, Content Director for Fleet Equipment. Welcome to Fleet Equipment Unscripted. We are out in California hanging out with Valvoline. We're talking engine protection. We're talking light-duty gasoline engines, though. I mean, think of those last-mile delivery vehicles, maybe utility, municipality, light-duty pickup trucks in commercial applications. Talking engine life, efficiency, performance. Engine deposits can form on gas engines and curtail the life of those engines. Valvoline says it might have an answer. The Restore and Protect oil that they just released says they think they can remove those engine deposits, turn back the time of that engine life, if you will. So let's see what we can learn. So, let's lay a baseline here. Let's talk about this. So gas engines.
Yes.
Engine deposits. Why are they bad? How do they form? Kind of run me through what those are all about.
So we'll start with how they form.
Okay.
So at the end of the day, an engine is a very severe environment. It's very hot. Temperature is your enemy in most cases, right?
Right.
Oil itself is made up of many different components.
Right.
You have base oil, you have polymers to help the viscosity, you have additives that help detergency, that help anti-wear, prevent wear in the piston area, in the valve train. You have things for friction modification, for fuel economy. All those molecules are a little bit different.
Yeah.
But at high temperatures, especially like in a piston area where you're seeing very high temperatures because of the combustion event,
For sure.
you can see breakdown of those components.
I see.
And the highest temperature is on the surface of the metal itself.
Right.
And so what those deposits are basically carbonaceous compounds that have broken down into basic carbon-based, could be hard deposits, could be varnish, and have basically applied themselves to the surface of the metal and have adhered themselves to the metal. Okay. Now, there's many different kinds of deposits.
Sure.
There's some that are temporary that you can wipe off with your finger. There's others that are a little bit thinner in thickness, and there's some that can get very thick. And in a piston, you have a combination of all those things.
Okay.
The bad thing about deposits is, several bad things about deposits. First of all, they insulate.
Okay.
So one thing that you want to do in an engine, you want the metal surfaces to be as bare as possible because they actually remove the heat from the engine.
Right.
There's coolant or antifreeze flowing around an engine to remove heat.
Right.
The combustion events are constantly generating heat in an engine. Getting the heat away is one of the primary things an engine oil does.
Okay.
Besides lubricate.
Right.
If you get deposits on the surface of that metal, you insulate and you can't get the heat out. That's number one.
Okay.
Number two is deposits also cause friction. So horsepower, you think fuel economy. If you don't have metal-to-metal interaction, or you don't have the proper clearances, the lubrication, you can get higher friction. And deposits can increase friction. It increases the distance between metal surfaces and can really cause problems from that perspective. Ultimately, those basically lead to shortening the life of an engine or minimizing the power or efficiency of the engine itself. Yeah.
Sure. And those deposits created naturally, are those contaminants within the oil as well, or is that also just kind of a natural occurring and it kind of runs the gamut?
Yeah, right, kind of exactly. Yeah.
Okay.
So there's the obviously the deposits themselves are a combination of really everything that's in the oil that we start with, right? And then you have byproducts coming across from the combustion event too. So you have acids coming over, you have fuel coming over around the rings, because rings aren't perfectly sealed.
Right.
So you do get what they call blow-by gases, which are combustion byproducts, fuel. You can get water. Right. Combination of all those things leads to sludge, right, which is a little bit more of an amorphous kind of, not a hard substance, but more like a gel or more like and that can also cause problems. Right. And then you also get deposits that form from that. So there's a lot of chemistry going on in an engine, a lot of components.
Far more than I understand, for sure.
And that can, and all of them are doing. Most of them are in there for a good reason, right? It's just that ultimately chemistry and the high temperatures and the environment tends to lead to breakdown of those components, which then can then lead to deposits on the surface of the metal.
I see, right.
Ultimately.
Right, because then going into the formulation, right, the formulation is complex. And yes, there's base oils that a lot of brands will have in common. But then Valvoline, I mean, you have this new Restore and Protect. Tell me about that. What goes into that formulation? What are you aiming to do with it here?
Yeah, we're excited about this, obviously. So you're right. So if you look at the baseline oil, right, or a finished oil that you buy on the shelf, right, there's always going to be base oil in there. 85% of it is base oil. The base oil selection matters too, and it also matters in Restore and Protect. There's viscosity modifier that control the, if you want a 5W30 or 020, the polymer helps to control viscosity. And then you have multiple additives in there to do different things. And that additive combination is what makes each oil unique.
I see.
And that's what Valvoline brings to the table, 150 plus years of formulating. We are constantly looking for ways to innovate and improve and differentiate our oils. And so 5 years ago, when we started the Restore and Protect development, it takes a while. These things don't happen overnight. It takes a while. You look at different combinations of additives to do different things. Okay. The four major reasons for engine breakdown are deposits, wear, heat, and friction.
Okay.
So when we 5 years ago started to look at a white paper, basically, okay, if we want to develop a new oil that's a new category, what would we do?
Right.
And we put together a combination of componentry that could help those things. And then you do basically a matrix, or what they call a design of experiments, where you look at combinations of those things.
Those additives, the componentry of the additives.
Those additives.
Okay.
And they can be detergents,
Okay.
they can be friction modifiers, they can be antioxidants, they can be a different combination dispersants, which are components that keep byproducts floating in oil. You don't want things to get to the surface of an engine. You want to keep them actually in the oil itself. Those combinations is what makes an oil unique.
Okay.
Those different combinations, it's hard to predict the performance of that. So when we started R&P, we said, okay, let's see what different combinations can do. You have to do on the testing. You got to do bench testing, engine testing, field testing.
Okay.
And we didn't know what to expect, really. You really have to do the testing. It's hard to model or predict what an additive combination can do. Yeah.
Okay. Well, just because of duty cycle or operating environment, or just all the alchemy that goes into whatever happens in an engine?
All of the above.
Okay.
Right. It really is a very hard environment to model or to predict what's going to happen.
Yeah.
So it really requires a lot of hard work behind the scenes and basically running the testing. And by testing, I mean engine testing. So actual put the oil in an engine, run it for a certain amount of time under a certain load cycle, certain drive cycle, like you mentioned, because that severity drives the amount of deposits. So you want to look at that. There are industry tests. So when I say industry tests, there's actually specifications out there like ILSAC GF6 that have engine tests that are agreed to by the engine manufacturers, you know, like your OEMs, Ford, GM, Chrysler, oil manufacturers like ourselves. They agree on a certain slate of testing that basically predicts or measures the performance of an oil. One of those tests, the Sequence 3H, measures deposits. Okay. So we use that test as sort of the rock or the foundation to help measure the performance of the oil, which ultimately led to Restore and Protect.
Okay, yeah, because going back to that, something you said a minute ago that I found interesting, create a new category of oil. You say category, I think of like API categories and different categories that go in there. So Restore and Protect, how do you see this as a different category? What's it doing that makes it, that differentiates?
Great question. Great question. So when we think category, we think really conventional, synthetic blend, synthetic, and then high mileage. Is a category that Valvoline invented over 20 years ago. Yep. That basically it basically takes into account and helps to improve the performance of older engines.
Right. Okay.
When we think of R&P, what I call Restore and Protect R&P, is a product that doesn't necessarily attack just the older engines, but also newer engines. Deposits form very quickly. When you buy a new car, within 5,000 miles, you're going to have deposits on an engine. And those deposits, and the things we talked about earlier, but the bad things they can do, you don't want that to happen. So we see Restore and Protect as a new category because it covers newer engines and older engines, and it also reverses the aging process. So it actually removes deposits. We have not seen in the industry an oil that's been shown to remove deposits like we've shown with Restore and Protect. And the great thing about it is we have data, we have visuals, we have great visuals of pistons that have gotten cleaner with Restore and Protect. And we have video of that. We have pistons that we have photos of that show that reversal.
So reverse. So like for example, I've got a 180,000 mile Toyota, that I'm running.
Yep.
So that would, you're saying the restore and protect. I get the protect on the newer engine, right? You start using that right away. You're going to keep it clean and looking nicer. But you're talking about, I mean, this is years. This car is like 11 or 12 years old now, right? You're talking about years of pulling that off the piston.
It is, yeah. You know, and engines, the OEMs have gotten so much better at making engines. Even 180,000 miles is not a lot.
This is what people keep telling me, but I can't believe it, right?
It's not a lot of miles on an engine. But if from your duty cycle perspective, a lot of people drive severely. You may.
I don't. You know what? I try to do my best.
But it's not your fault. It could be that you're towing the boat. It could be that you're kids to practice. It could be you're sitting in traffic.
Well, light duty engine, you get into some of those vocational applications too, where you have even some of the last mile operations, or you get into some of the construction stuff, or maybe you're running a Ford F-150 and towing your boat on the weekend, right?
The load on that engine is really what drives the severity inside the engine. Yeah. So what the oil sees, what the engine sees, what the metal parts see. And that is what I mean by severe. Not that, you're driving.
Not that I'm a terrible driver. I appreciate that.
But engines like to drive fast. I mean, if you're at the end of the day, they want to drive in a very small, not a small window, but a very
that efficiency window. Running at kind of low RPMs, higher speeds, keeping it right in that sweet spot.
They hate low RPMs. They don't like idling.
Right.
They don't like starting and stopping. So they'd rather be on the highway going 65, 70, 75 miles an hour. So that severity is what really drives that. And so if you look at what our Restore and Protect does, it actually helps to alleviate the issues that brings. So it can actually remove deposits that form because of that type of driving.
Right. So let's say I'm a light duty commercial fleet, right? We all see the Amazon vans running around our neighborhood, FedEx vans. You think of maybe some other vocational applications, municipalities running light duty trucks. Maybe they have some equipment in the bed, that kind of thing. What's important for them to think about in terms of that engine oil and protection? They're running those duty cycles that are start-stop, and you're never really getting up to those highway speeds. How does this impact it?
Yeah, I think this is where Restore and Protect actually is really, really needed, right? Those vehicles, like you said, are start-stop, what I call severe driving. The engine is on
in a gasoline world.
It's severe driving. The vehicle is driving for maybe a couple miles or half a mile or a quarter mile. It's stopping. It's starting. That engine is taking a beating, and it's not going to be happy in that regime, right? So the oil has to perform there. And if you don't have the proper oil in there, or doing the proper maintenance and doing proper oil training, if you aren't doing that properly, then that engine's going to get stressed and its life could get shortened dramatically. Restore and Protect would really help there because obviously because of that duty cycle, deposits are going to be formed. You're going to have wear potentially because of the loading on the bearings and the valve train. You're going to have a lot of different types of performance there you want to worry about. Restore and Protect will help you with that, right? So it'll actually number one, it'll help remove deposits that have already formed.
Right.
It'll minimize or eliminate the additional deposits that are laid down. It'll also help with the wear issue. So Restore and Protect, and the Protect side really is about protecting the metal. That could be the valve train, that could be the cylinder wall, the pistons, rings themselves. That area needs to be protected, and Restore and Protect has anti-wear additives to help with that. So that drive cycle for that type of application is exactly what Restore and Protect would really benefit from.
Well, yeah, and you mentioned what's interesting there because commercial vehicles, if they're not rolling, they're not making money, right? So downtime is something I definitely want to avoid.
Yeah.
You mentioned the oil drain intervals, which often is reserved for like the heavy duty world and setting those oil. You don't have as much wiggle room here on the gas side. But is there the other component that goes along with that is oil analysis? If I'm a commercial customer, I've got my regular maintenance intervals. Is there an opportunity if I want to test out Restore and Protect, work with you all? Do you do oil analysis on it?
We do.
Is that something customers can get involved with?
Absolutely. So we love data. We have 100 Valvoline. You can call our helpline, right? And we have actually test kits that will send you a little bottle. You can put oil in, and that is really we do a lot of that, right? So you can look at a used oil and look at the wear metals that are in there, the oxidation, the viscosity change, and you can get a lot. We call it an autopsy. You can get a lot from that analysis and say, hey, you know what? Either your oil's doing its job or it isn't, or you can really help in terms of defining what you may or may not be doing well from that perspective, right? Are you using the right oil? Are you doing the right oil drain interval? Are you doing things that are helping your engine, or is it hey, you're ready? You're probably setting yourself up for failure down the road.
Right. Well, and it's interesting in that light duty gas side because you can kind of set the baseline. Even if I've been running some vehicles, let's say it's a year or two old, if I get one of your test kits, send it in, then switch to Restore and do 2 or 3 oil change rounds, then I can kind of see the ROI at work right there.
Exactly. It's good to have a baseline of, because like you said, every engine's different.
Right.
Every drive cycle is different, right? And so you set that baseline of performance. and then you can compare against that. And we have many different ways to look at engine performance, or oil performance, I should say, right? Our lab in Lexington has lots of different tests we can run to look at how that oil is aging, and maybe even how the engine is aging.
Right.
Because that's where wear metals come in. That's where you can look at oxidation of the oil itself. You can look at a lot of different things there to really give you an idea how that oil is performing.
Oh yeah, and help me plan even my replacement cycles and what I'm going to need in vehicles down the line here.
Yeah, the prediction piece of it, we can trend things and take a look at how that oil is performing and really see, okay, well, is it getting worse?
Right.
Because sometimes, you see these where you have like a linear increase in, say, wear metals. Then all of a sudden you see an increase in that because you've reached a point where things are getting worse and worse and worse, and that can get exponentially worse. And then you really are setting up for a problem, harder to come back from that.
Right. Very interesting. Well, hey, I appreciate you taking the time. I learned a ton. Appreciate it.
Well, I really appreciate it. Thanks for the time.